Hello friends, so today we will be discussing um, population growth and decay, Fibonacci sequence, and golden ratio. So this is in continuation with the previous lesson with the introduction to mathematics in the modern world. Okay, so let's first discuss population growth and decay. So when we say population, this is the number of members of a given domain. No? For example, we're asked to find how many people are there, let's say, living in a specific city. No? So that is what we call a population. How many animals are there inside the zoo? That is considered a population. No? So how many bacteria are being observed under the microscope, no, seen under the microscope, that is also an example of population. As long as they belong to the same domain, no, or same category, no, they can be considered as a population. Okay, so how about growth and decay? So when we say growth and decay, this is the increase in the number or the decrease in the number respectively. So from the word itself, growth, no, we are seeing an increase, no, an increase in the current numbers, no, after a given specific time. Or kapag decay naman, we are seeing a decline, no, a decline in the numbers as compared with the initial count. So we have here our formula, no. So the formula for the growth and decay, population growth and decay, A is equal to P e raised to RT. Okay, where A is the target population, or that is the population after a specific time, no, yung letter T natin. Then P is the initial population, what is the current, no, or depende, no, depends on the reference. Basta it is the start, no, it is the starting count, no, yun yung initial population. Then E is the Euler's constant, so we will be using calculator here, no, so we will not be approximating any number, we will be using the exact Euler's constant. So later we will see how are we going to display the Euler's constant in the calculator. Then we have R, that is the growth rate. So for R, no, we are not going to input here the percentage, no, or the whole number percentage, but rather the decimal equivalent, no. So for example, if the growth rate is 10%, we're going to input 0.1, no. So from percentage, we are going to convert it into decimal. Then T is time, or moreover time difference, no. So we are not after the kung ano yung specific month, no, but rather the time difference between the time that is being asked versus the time reference, no, yung start ng initial count natin. Okay, so game, let us try, no. So for example, we have here the exponential growth model. A is equal to 30 e raised to 0.02t describes the population of a city in the Philippines in millions after 1995. So first is what is the population of the city at 1995, then what will be the population after 2 decades. So first, no, we are going to apply, no, the formula, no, but we already have here our population model, no. So this is actually the one that we are going to use, no. Ito na yung population model na natin, yung formula na gagamitin natin. Okay, so for the solution, okay, so again, ano, let's write the model, no. A is equal to 30, this is in millions, so never forget, no. So the 30 here is in millions. Then we have e raised to 0.02, that is 2% t, no. So if you're going to compare it with the formula, no, yung sa formula na binigay ko kanina, so we have this one is, of course, this is still A. 30 is our P, no, that's the initial count, no, that's the initial population. Then we have 0.02 is our R, or the growth rate. In this case, this is growth rate. Then we have T, no, that is the, of course, the time difference, no. So if we're going to check, no, what is the population of the city at 1995. Okay, so we're going in order for us to determine what is T, we need to go back and check dun sa problem, no. Ano ba yung reference natin, no? Sabi, itong model na to starts at 1995. So ibig sabihin at year 1995, no, ito yung population natin, is equal to e raised to 0.02 p, no. So lagay ko lang dito time ref or time reference is 1995. So this is in years, ha. Ayan, kapag nakita nyo ganito, automatic in years yan. Lalo kapag population ng tao yung pinag-uusapan. It will always be, or most of the time be, in years, no? So kasi once a year, I mean sa isang I mean sa panganganak, 'di ba 9 months naman yung ginugugol. So nevertheless it will be in years. Okay, so time rep is 1995. 1995 is also the time being asked for. So we're going to get the time difference. 1995 minus 1995 is 0. So meaning our t here is 0. So for letter A is equal to 30e raised to 0.02 times 0. Okay, kasi nga, there's no time difference between 1995 and 1995. Okay, so 0 times 0.02, that will give us 0. Then any number raised to 0 is equivalent to 1, no? So this is equivalent to 1, meaning our population at 1995 is 30 million. Kasi 30 times 1, and remember 30 is in million, so we have 30 million. Okay? So yeah, no? So 30 million. This is for letter A. How about for letter B? No? So for letter B, what will be the population after 2 decades? No? So we're going to use the 2 decades kasi sabi nga dito after. Ito yung pinaka clue word natin dito, after, meaning after 1995, 2 decades after 1995, ano yung population niya? No? So we have A is equal to, using the same model still, 30e raised to 0.02, no? Multiply to how many years are there in 2 decades, no? So obviously a decade is equivalent to 10 years, no? So 2 times 10 is 20. So we have 20 years time difference. So we have 30e raised to 0.02 raised to 20. So of course we cannot compute this manually because we have the Euler's constant. So let's use our calculator. Yan. So, labas ko lang yung calcio ko. Okay. Game, no? So, we have here, let's type this one. 30. Yan. Then, para mapalabas natin yung e raised to, no? Kasi there are two e's here. The constant itself at saka yung e raised to, no? Yung merong exponent. So, we're just going to press shift, then ln. Ito, yung ln. No? So, we have ln para e raised to. Then you can group it, no, para mas sure, pero it doesn't matter naman actually. 0.02 times kung ilan yung ano, no, 20. Ayan. So we have therefore 44.7 or 44.754 or 55. No, so yun yung gagamitin natin. Okay? So therefore the population after 20 years is 44.755. Round off na lang natin, no, million. Or if you're going to input the exact, no, yung exact na value ng ating population. So mula dito, since this is remember, 'di ba, yung 30 natin is in million, so we need to multiply this with 1 raised to 6 times 10 raised to 6, no, kasi yun yung conversion natin from base to million. So we have we have 44 or 44 million 754 741. No, bakit siya naging 41? Actually, kahit pa 0.01 or 0.1 yung lumabas dito sa ating calculator, we're going to round it up. Bakit? There's no such thing as half or not whole people, no? Wala namang taong pinanganak na kulang, no? I mean, yung hindi buo, let's say walang paa, so yun yung equivalent ng 0.9, no? Parang ganun. So there's no such thing as that. So I'm just going to round it up, no? And count the decimal as 1 person. So this is the answer. Okay, so baba ko lang yung calcu. Yan. So this is our answer. Yan. No? So that's how we compute for the population growth and decay. So another example, no? So we can practice. So we have here the current population of cats at the Cat Island, no, sa Japan, that is 45,000. How many cats will there be if they're the question lacks, no? Let me include after let's say after by the way, no, the rate of increase is, let's say, sorry ko lang yung question. Let me add one. Okay. 12.5% per, let's say, per, or rather every, no? Let me change that one. Every 6 months, no? Let's say after, how many cuts will there be if the rate of increase is at 12.5% every 6 months after, let's say, 2.5 years. Okay, so yan, mas complete na yung ating question. No, so the population of cats at the Cat Island is 45,000. For 45,000. How many cats will there be if their rate of increase is at 12.5% every 6 months after 12.5 years? So we're going to use the formula, no? Same formula. So for the solution, so same formula, A is equal to PE raised to RT. Okay, so we have, of course, yung after population natin, no, yung target population natin, the base population is 45,000. Ayan. E raised to, what is our rate, no? So that is, sorry, let me fix this. Ayan. So the rate will be 12.5%. So if we're going to convert it from percentage to decimal, that will be 0.125. Okay, so move lang tayo ng 2 decimal places, no? From to the right rather, to the left rather, sorry, to the left, no? So para makuha natin yung decimal equivalent. Okay, so since this is every 6 months, ito guys yung critical, no? So you need to be careful at what rate yung given, no? I mean, ano yung time reference ng given? For example, in this case, 6 months. So, we cannot use this as directly substitute lang natin yung 2.5 years. Bakit hindi equivalent kasi 6 months sa 1 year? No? So, in every year, no? So, in every year, we have 6 months. So, if we're going to convert 6.5 years into 6 months, that will be how many? That will be 5, no? So, ibig sabihin, ang time natin is 5. Okay, so you need to be careful. Okay, so we have here 45,000 e raised to 0.125 times 5. So labas natin ulit yung ating calcu. Ayan. So we have 45 times 10 raised to 3. So that is equivalent to 45,000 if gusto nyo mas mabilis mag-type. Then shift LN para lumabas yung e raised to. That is 0.125 times 5 basically. No, so we have yan 84,071.6 or 0.7. So since we have a decimal place, no, let's just add 1 kasi wala namang kalahating pusa, di ba? So let me put the calculator again down. Or okay, let me put it right mo. Let me write muna. So we have this is equal to 84,000 0.72, no? Kasi meron tayong decimal place nga. Ayan. Okay. Ayan. So, 84,072, no, cats. So, after 2.5 years, ganito na karami, no? Halos dumoble na yung number of cats natin sa Cat Island with the given rate, no? So, ayan. Okay, so that is the answer. So, baba ko lang yung calcu. Ayan. Okay, so that's basically, no, how we compute population growth. Again, no, this is not only applicable for humans and for animals but also for bacteria, usually bacteria. At saka yung half-life, no, that is yung yung half-life, the decay, no, yung decay ng ng mga subatomic particles natin, no? So, yun, pwede natin gamitin to, no? Yung ating model A is equal to PE raised to RT. Okay, as long as given yung ating, of course, the initial population, then we have the rate and the time, no? So, ayan. Okay, so let's move on. No, let's discuss the Fibonacci sequence. Okay, so this is the fourth, no? So, next meeting, actually, nauna yung pang fourth kasi sa unang tatlo. No, we will be discussing the different sequences, but papauna ko nang i-discuss si Fibonacci kasi medyo separate yung property niya as compared with the other three. No? So, the other three will be the arithmetic, the geometric, and the harmonic sequences. So, let's focus muna dito sa Fibonacci sequence. So, Fibonacci sequence is defined as the sequence of numbers whose terms are the sum of the preceding two terms. So, take a look at this table. So, we have two rows, no? So, we have n, that is the place value, no? Kung pang ilang term yung hinahanap natin or sa pang ilang term ng Fibonacci sequence. Then, we have x sub n, that is the actual term, no? So, we have 0, no? 0 to 10. This is the first 11 terms, no? That is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So, if we're going to inspect, no, tignan natin, okay, so, yung, let's say this one, yung 2, no? So, kung mapapansin natin, if going to inspect yung previous terms, no, pag pinag-add natin to, no, itong dalawa, ito yung lalabas. Okay, dun papasok itong definition natin na to. No, yung ayun nga, yung sum of the preceding two terms. So we have f sub n. So in other books f sub n yung ginagamit, but in other books x sub n. No, so we have x sub n is equal to x sub n minus 1, that is the preceding term, okay, plus x sub n minus 2, that is the second preceding term, no, yung succeeding term niya. Okay? So quick history lang, no, about the Fibonacci sequence, no? So the sequence is actually conceptualized by Leonardo Pisano Bogoglio, no? He lived from 1170 to 1250 in Italy. Okay, so actually Fibonacci is not his real name but rather a nickname, no? So Fibonacci, it has a meaning, that's the Italian for son of Bonacci, no? So yun yung meaning na Fibonacci. Okay, si Leonardo, siya din yung nag-introduce ng Indo-Arabic numerals to Europe. No, as we all know, 'di ba, meron tayong Roman numeral system. 'Di ba, yung I, 'di ba? V, no, kung ano-ano letters pa. Okay, so that's the Roman numeral system. However, if you're going to use the Roman numeral system in large numbers, but it is actually quite hard to construct, 'di ba? Kaya doon pumapasok yung advantage ng Indo-Arabic numerals, no? Yung Indo-Arabic numerals, yun yung mga numbers na ginagamit natin yan. Yung from 0 to 9, then umuulit na lang ng umuulit, no, habang lumalaki yung value natin. Okay, so si Leonardo ang nag-introduce nun sa Europe. Okay, so upon his introduction of Indo-Arabic numerals, doon nag-start ang pag-boom ng field of mathematics sa Europe. Okay? And actually, si Leonardo was not the first to use, no, to actually invent or discovered, no, okay, or use, no, or let's say just use, no, the sequence, but rather it was the Indians, no. So 100 years before Leonardo, existing na actually yung Fibonacci sequence. Hindi lang kumbaga wala lang siyang pangalan. Okay, hindi lang siya na materialize. Okay, so kaya napunta kay Leonardo yung credit kasi siya yung materialize, siya yung nagpangalan, and siya yung nag-describe ng property nung sequence. Okay, so aside from the table that we had on top, okay, so meron tayo actually Fibonacci sequence below 0. Okay, so using the same format, no, n is the kung pang ilang term, then x sub n is ano yung term. Okay, so ito yung starting natin kanina. Diba? Yung 0, 1, 0, 1, 1, no? And yung nasa left side niya, yun yung mga negative terms, no? So we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, no? Ayan, so we have ano ba yung mga terms, no, on the negative side. Okay, so we have 1 for negative 1, we have negative 1 for negative 2, we have 2 for negative third or negative 3. So we have negative 3 for negative 4, 5 for negative 5, negative 8 for negative 6, so on and so forth. So ano yung napapansin ninyo, no? Sige nga, you can pause the video and check ano kaya yung parang, let's say, common, or rather, common tuloy. Ano yung kakaiba, no? So, yan. So, tama, no? Kung mapapansin ninyo, alternating yung signs. Starting from positive, this one is negative, then this one is positive, this one is negative, this one is positive, this one is negative, so on and so forth. No, so paano na nabuo to. So if going to apply no yung rule natin, no yung hard rule natin. So 'di ba, some of the two succeeding terms. So we have, let's take negative 3, the negative fourth term, yung negative 3. Yung previous to niya, pag kinuha natin yung sum, we have negative 8 plus 5, that is negative 3, which makes sense. Diba? So we have negative 5 plus negative 3, or simply 5 minus 3, that is positive 2. Then we have 2 plus negative 1, that is positive 1. Then we have negative 1 plus 1 is equal to 0. No, ito na yung start nung nauna nating diniscuss na Fibonacci sequence. Okay? So, yun lang naman yung ano dito. Okay? Nadagdag. Okay, so what's unique with Fibonacci sequence that's not found in other sequences? No, in any other sequences. So first, no, it makes an infinite rectangle, or what we call the golden rectangle. So kung mapapansin niyo, no, I have here sets of squares, okay, whose sides are the terms of the Fibonacci sequence. So start tayo dito sa pinakamaliit. Zoom ko lang ng konti, no. Ayan. So this one, yan yung 1-1 natin, 'di ba? Yan yung 1-1 natin. Then we have yung nasa taas niya, ito, okay, ito, yan yung 2, 'di ba? Then yung nasa tabi niya, ito, this is 3. Then 5, 8, 13, no? 21, 34, so on and so forth. Okay, so yun yung one unique characteristic ni Fibonacci sequence, no? So it can create actually the golden rectangle. And this golden rectangle, actually, no, later makikita natin saan ba ito ginagamit, ano yung purpose niya. Okay, next, another unique characteristic of the Fibonacci sequence is that it makes an infinite spiral as well. This is what we call the golden spiral. Okay, so yung mga kanto, no, from end to end, okay, if we're going to trace a spiral maintaining the distance, no, so makukuha natin tong golden spiral. Ayan. Okay, so later, no, another applications ng golden spiral makikita natin. Then we have, last is the ratio of the succeeding terms. Okay, so that is the upper term divided by the lower term converges to one value. Let's say, no, I will take the lower terms, no, as A, then the upper terms as B. Then we have R, no, yun yung ratio. Okay, yun yung ratio. We have R is equal to B over A. Then, let's put the terms, no? Succeeding. Okay, we have 1 divided by 1. We are going to start with 1 kasi 1 divided by 0 is indefinite, no? Or undefined. Okay, so not indefinite, but rather undefined. Okay, so that's undefined. So, we have 1, no? 1 divided by 1 is 1. 2 divided by 1 is 2. Okay, then we have bababa ulit tayo. 3 divided by 2 is 1.5. Then we have 5 divided by 3 is 1.667. 8 divided by 5 is 1.60. 13 divided by 8, that is 1.625. And so on and so forth. If you're going to continue this, we will actually converge to one value. Let's say, no, I will take this value 55 and 34. No, so if we're going to divide this, we will get 1.618. And this 1.618 is actually what we call the golden ratio. So, let's discuss golden ratio before we go back, no, dun sa ating Fibonacci sequence. So, golden ratio, ito yung kanyang actual value, pero this is not yet complete, no? So, that is 1.61803398874989484820, so on and so forth, no? So, mahaba to, no? Just like pi and Euler's constant, non-repeating, non-terminating decimal siya. Okay, so sabi nga, the golden ratio is the most irrational number, no? This is an irrational number, actually. Okay, so saan ginagamit si golden ratio? So, ito yung mga some of the applications, no? Art, photography. So, if you're familiar with the rule of thirds, no? So, it was derived in golden ratio. Also yung by in placing the object, no, yung pinaka-aesthetic, yun yung pinaka-term actually. Pinaka-aesthetic na na placement ng objects is actually following the golden ratio, particularly the golden spiral and the golden triangle. Triangle tuloy. Golden rectangle. Okay, so, and of course, architecture, no? Sabi nga natin, yung mga aesthetic na bagay. No? So, one example is the Parthenon sa Greece. Ito, kung makikita ninyo. So, this was actually based in the golden ratio. No? So, ayan. Then we have here, ito yung modern application niya in architecture. This is a house in US, no? So, pinattern yung dimensions niya with the golden rectangle, actually the golden rectangle, no? Which also abides the golden ratio. Okay, so another one is the snail shell, no? So that's what we call the nautilus, no? So yung nautilus ang tawag dun sa shape nung spiral, no? Na nabubuo dun sa shell ng snail. No, so the golden ratio is known for different terms. Okay, so the golden mean, the divine proportion, the divine ratio, so on and so forth. So yun yung mga yun yung mga yun yung mga terms, other terms na kilala si golden ratio. Okay, so actually yung 1.618 so on and so forth, di nyo naman siya kailangan tandaan ng buo. No, bakit? We actually have the definite value of the golden ratio. So this is denoted by the small letters C, no? So I do not know if I pronounced it correctly, pero here's the spelling. Ayan. So yan yung Greek letter na yan, no? So yan yung notation natin for the golden ratio. And the actual value is 1/2 plus square root of 5 over 2. No, so paano tayo nag-arrive dito sa 1/2 plus square root of 5 over 2, which is actually equivalent to 1.618 so on and so forth. No, so let's define the golden ratio by itself. No, so we have here C is equal to 1 plus 1 over C. So again, alam naman natin na 1.618 yung equivalent ng C. So we have 1 plus 1 over 1.618. So that is equivalent to 1 plus 0.618. So the golden ratio, 1.618. Okay, so, pero paano nga nag-arrive dito sa 1/2 plus square root of 5 over 2? So, let's do some algebraic manipulation. Let's say we do not know that 1.618 is the value of C. No, so, I will multiply this with C, no, in order to eliminate the denominator dito sa side na to. So, we will have C squared is equal to 1, or rather C plus 1. No, so, and if we're going to transpose the right side to the left side, no, so we will arrive with C squared minus C minus 1 is equal to 0. And since hindi nga natin alam kung ano yung value ng C, we will treat this as a variable, no? So, and this is in the form of a quadratic equation, no? So we're going to use the quadratic formula. So we have C is equal to, the quadratic formula is negative B. Okay? We're just going to get the principal root. No? Principal root lang kailangan natin. So, hindi ko na ilalagay yung plus minus, but rather plus na lang. No? Kasi, principal root lang naman ang kailangan natin. We have square root of B squared minus 4AC. Okay? All over 2A. No? So, yan yung natin. Formula natin. Then let's substitute. Ano ba si B? Ano si A? Ano si A? Ano si B? Ano si C? So getting the coefficients of the quadratic equation. So this is A. Diba? This is B. This is C. So we have 1 for A, negative 1 for B, and negative 1 for C. So let's substitute. We have negative of negative 1. Sorry. Plus square root ng negative 1 squared minus 4 times 1 times negative 1 over 2 times 1. No? So we have, let's simplify. We have here negative 1 times negative 1, that is positive 1, plus square root ng negative 1 squared is 1. Then we have negative 4 times 1 times negative 1 is positive 4. So we have 1 plus 4, that is square root of 5 over 2. So pag-iwalayin lang natin, no? So this will give us 1/2 plus square root of 5 over 2. Doon nang galing yung definite value natin na 1/2 ito, yung 1/2 plus square root of 5 over 2, which is equivalent to 1.618, no? Approximately. Okay, so that's it for the golden ratio. Okay, let's jump back dun sa ating Fibonacci. Or rather, sorry, meron pa pala. No? So, we have here one interesting concept related to golden ratio. This is what we call the Kepler's triangle. What's unique with the Kepler's triangle is that the idea is the combination of the golden ratio and the Pythagorean theorem. Alam naman natin yung Pythagorean theorem, that is equivalent to c squared is equal to a squared plus b squared, di ba? Yeah. And if we're going to use, no, yung kanina yung nakuha natin, 'di ba? Ito, saan na 'yon? Ito to. No. As i-match natin siya sa Pythagorean theorem. So, sulat ko lang dito sa baba. You have c squared is equal to c plus 1. No? So, c squared is c squared. Then we have c is equal to a squared. Then we have 1 is equal to b squared, basically. So, alam naman natin na yung c, a, and b, those are the sides of the right triangle, no, for the Pythagorean theorem. So, if we're going to convert this, no, into sides, so we will get c. Kunin lang natin yung square root each, no? Kunin lang natin square root na ito lahat. Ayan. So, we have c for the hypotenuse. We have square root of c for the longer side and or kahit magkabaliktad, okay lang. And we have 1, no, for the other side. Okay, so another fun fact, no, is that the ratio of the sides of the Kepler's triangle, that is c square root of c and 1, is actually a geometric sequence. Okay, so I'll leave it up to you guys, no, determine what is the common ratio of the geometric sequence. Okay, so you will learn this later in the next topic, no, yung geometric sequence natin. How are we going to compute this? Okay, so or what are we going to use to compute this? Okay, so yun, no, that's the golden ratio. Okay, and how are we going to compute for the nth term of the Fibonacci sequence? Kasi actually, it is quite tedious, no, to compute the terms of the Fibonacci sequence ng mano-mano. Yung isa-isa natin i-add, no? Paano ko sobrang laki na ng numbers, that is actually quite a headache, no, or quite a headache. So instead, we can use the golden ratio to compute for the nth term of the Fibonacci sequence. So that is x sub n is equal to c raised to n minus the quantity of 1 minus c raised to n all over square root of 5. No, so let's say for example, we're asked to find what is the let's say 16, no, since 16 is my birthday. Ayan, yun lang yung reason. So we let's compute, no. So we have c raised to 16 minus 1 minus c raised to 16 over square root of 5. No, so yan, no, we can compute. So paano natin ko-compute? I advise you use, guys, the 1/2 plus square root of 5 over 2 na value kasi sakto yung makukuha ninyo. Unlike dun sa approximation natin 1.618, it is actually applicable for smaller terms, no, yung mga medyo malalapit sa zero na terms. Pero sa mga large terms, medyo malalayo na yung nakukuha natin. So instead, we will use the 1/2 plus square root of 5 over 2 na value ng c. No, so palabasin ko lang ulit yung aking calcu. Ayan. So we have ayan. So para hindi kayo mahirapan, guys, actually you can store the value of c, no? So we have 1/2 plus square root of 5 over 2. So how can we store this one? No, so we have shift RCL, no, dapat lumabas yung STO dito sa taas. Then you can pick any variable here. You have lots of variables, a to f tas x, y, and m, no. So any variable would do. Pero ayoko na pahirapin sarili ko, letter A na lang, no. So pag nakita niyo na to, yung arrow A, no, ibig sabihin stored na siya sa letter A. So kahit patignan natin alpha, the negative sign for letter A, yan na yung value niya. Okay, so yun na lang yung gagamitin natin. So we have a raised to 16 minus minus 1 minus a quantity, of course, raised to 16 over square root of 5. So this will give us 987, the exact 16th term of the Fibonacci sequence. So we have 987. So, for example, the 7th term, no? Let's validate. Kasi 'di ba meron tayo dito, no? Kasi it's quite tedious nga, no, to validate. So the seventh term kasi July ako, so 7, no. So let's try na mapalabas yung 13. Dapat 13 yung lalabas. Okay, so we have here, let's say, no, the 13th term, or rather the 7th term of the Fibonacci sequence. So we have C raised to 7 minus 1 minus C raised to 7 over square root of 5. No, so balik ako dito sa calcu, no. So if you have already pressed AC, retype nyo na lang, no. Pero I advise, no, kung hindi nyo pa naman napipindot, huwag nyo napindutin, no. Arrow keys na lang, so you can change the values, no. So we have 7, then make sure yung kabila is also 7. Ayan. So the 7th term of the Fibonacci sequence is 13. Okay, so ayan. Okay, so that's it, no? That's the discussion for population growth, Fibonacci sequence, and golden ratio. So I hope you guys learned something. Okay, so stay tuned. Next topic, we will be discussing the different sequences and series, no? So the arithmetic, geometric, and harmonic sequences. So thank you, stay safe, and God bless.